In this video, we want to review the operation of IEEE 802.1q trunking, or we typically say just .1q trunking for short. The idea is we might have switches like we see here with ports in different VLANs, and each of these two switches have clients belonging to VLANs 10, 20, and 30. How do we pass traffic from the VLAN 10 computer on the top switch to the VLAN 10 computer on the bottom switch? Well, I suppose we could have a link to interconnect the switches that just carried traffic for VLAN 10, and we could have another physical link that just carried traffic for VLAN 20, and so on. But you can see that's not scalable at all. What we can do instead is create a special type of connection between these switches called an 802.1q trunk. And this 802.1q trunk has a very unique ability. It is able to carry traffic for multiple VLANs over the same physical link. So here, traffic for VLANs 10, 20, 30, they're all flowing over that .1q trunk. And the way the destination switch is able to know where to send that traffic is it looks at the VLAN identifier contained in one of the tag bytes that get added on to this trunk. We add on 4 tag bytes. There is one exception. There is a special VLAN, and by default it's VLAN 1 on our Cisco Catalyst switches, but we call that special VLAN a native VLAN. What's unique about a native VLAN is that it doesn't get tagged. We don't add 4 bytes to that native VLAN. And that means if a switch receives a frame coming in over a trunk and it has no identifier, it doesn't have those 4 extra bytes added, then it's going to assume it belongs to the native VLAN. And it knows it should only send it out a port belonging to the native VLAN on that switch. And as a result, it's very important that both switches agree that for this trunk, they share the same native VLAN. Otherwise, we could do what's called VLAN hopping and go from one VLAN on one switch to another VLAN on another switch because we aren't explicitly marking a native VLAN. It's just that the absence of a marking implies the VLAN membership. Now let's take a closer look at the frame format of a .1q trunk. Here we see a traditional Ethernet frame. But with a .1q trunk, we insert these 4 bytes that we see here between the source address and the type field in an Ethernet frame. And we do that again for every VLAN except the native VLAN. And there are VLAN bits in amongst these 4 bytes that indicate VLAN membership. And when we're doing trunking between switches, 802.1q is what we typically use. That's an industry standard. You may be working on some older configurations, however, just to be aware of this, you might run into an ISL trunk. That's an inter-switch link trunk. That's a Cisco proprietary way of doing trunking between Cisco Catalyst switches, and it's really not what's preferred these days. It's got a large header. It's got 30 bytes that we add on. There's 26 bytes of header and 4 bytes of checksum. That's a lot to be adding to our frames. And because it is a Cisco tagging mechanism, it might not work well with other vendors. So in almost all cases today, we're going to be using .1q trunking. Now this was a review of .1q trunking operation. In our next video, we're going to take a look at some common troubleshooting issues that we might run into with .1q trunks.